Okay, so we're moving on now to something called the rigging method. Now this is a way of proving a method that is used to prove divergence or convergence in situations that are not easily done using the methods we've shown previously. So the algebraic manipulation is difficult, and this way it sounds dodgy, okay, because of the word rig in it, but it still is accurate, provided we can show that it is. Okay. Now, generally speaking, it is only used when we've got trig problems, used when trig ratios are present in the sequence, or when the powers of n, when the powers of n are greater than 2, so 3 or higher. Okay, that's a general rule where we would use it. Okay, if we had powers of 2, then we would use the quadratic formula as we have already. Okay, so trig ratios or powers of n that are greater than 2. Okay, so let's look at an example and see how it works. So, prove that the sequence sine n over n cubed plus 3n converges. Now, by observation, it appears that the sequence sine n over n cubed plus 3n, okay, it appears that that sequence converges to 0. How do we know? Well, okay, so the value of sine n, whatever n is, sine will fluctuate between -1 and 1. But our denominator continues to increase. Okay, it continues to increase infinitely, and so as the denominator gets very, very large, the overall value of the term gets closer and closer to 0. Okay, so we need to prove then that it converges to 0. So our sequence sine n over n cubed plus 3n converges to 0 if given any epsilon greater than 0, however small, there exists a number dependent on that value such that the absolute value of sine n over n cubed plus 3n minus 0 is less than epsilon for all terms greater than that number n. So let's work through it. Sine n over n cubed plus 3n minus 0, so the absolute difference of that is less than epsilon if sine n over n cubed plus 3n minus epsilon is less than epsilon. That's true if... Now, where do we go from here? Well, let's just take a step back. We need to we need to do some rigging at this point. So how can we rig that? Well, the absolute value of sine n is less than or equal to 1. Okay? Whatever the value of n is, sine n will fluctuate between -1 and 1. So the absolute value of that will be less than or equal to 1. So that means that the absolute value of sine n over n cubed plus 3n is going to be less than or equal to 1 over n cubed plus 3n, which means that we can say that 1 over n cubed plus 3n is also less than epsilon. Okay, so if we can prove that 1 over n cubed plus 3n is less than epsilon, then we know that our previous statement here of sine n over n cubed plus 3n also will be less than epsilon. So we just need to prove this latter statement now, and that gets rid of our problem of having sine there. Okay, so if 1 over n cubed plus 3n is less than epsilon, if 1 over n is less than epsilon. Now you might think, what the heck has happened here? Okay, well, I've rigged it again. Okay, I can do that in this case because we can say that 1 over n cubed plus 3n is less than 1 over n. Okay, and this is what I mean by we use it when we've got powers of n that are greater than 2. Okay, we've got power of n here of 3. Okay, we can't easily deal with that, so we are going to rig it here. Alright, so because 1 over n cubed plus 3n is less than 1 over n, because the denominator in n cubed plus 3n, okay, that is bigger than n, means the overall term is less than 1 over n. Okay, we can continue this statement. Okay, 1 over n is less than epsilon. Okay, and we progress further. So that's true if n, taking reciprocals, n is greater than 1 over epsilon. Therefore, we'll let our capital N equal 1 over epsilon, and thus our sequence sine n over n cubed plus 3n converges to 0.